Hello, my friend. Welcome to the Code with Reza channel. My name is Reza and I'm here to teach you Python from scratch. So sit back and enjoy the course. This is the second part, so let's talk about lists. In Python, lists are mutable sequences. You can change them. This is how to define a list. First of all, let's start the Python software. Okay, so this is how we define a list. This is a list of one, two, and three. We can say A equals one, two, three. Or we can use the list method. List one, two, three. Both of them are right. It is possible to nest lists. For example, let's say A equals one, two, three, and B equals A, B, C. We can say C equals a list of A and B. Look at C, a list of lists. So this can be nested. Now a trick. Instead of creating a list like this, A, B, C, and something like this, we can easily do this. We can say A equals to list of A, B, C, D, E, F, G, whatever, and then we can close this. So look at A. Interesting, isn't it? Python is awesome. Now we have some sequences in Python, like strings, like lists. There are some common sequence operations that are common among all the sequences in Python. Let's talk about these operations. Let's say t equals 1, 2, 3, and s equals 4, 5, 6. Then we can test if 1 is inside T by 1 in T. Because 1 is inside T, it says true. Or we can say 4, which is not inside T, 4 not in T. Again, it's true because 4 is not in T. Something very interesting is if we want to combine these two lists, we can easily say T plus S. That's all. Now we have 1, 2, 3 from T and 4, 5, 6 from S. Very easy. We can also multiply a list by a number. We can say T multiplied by 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Interesting. We can get an element from the list by its element by the element index like T0 is 1. Or we can slice a list like T from 0 to 2. These 2 is exclusive, means it starts from 0 up to 2, but not including 2. So here we look for T index 1 and 2. So let's have a look. This is 1 and 2. Or we can access the last element in T by minus 1. As you know, minus 1 means the last element in the list. So this is 3 because T is 1 to 3. Now we can say from third element from the last of the list. So this is the minus 1, minus 2, and minus 3. So the third element from the last of the list till the end. T minus 3 and the end. It's 1, 2, 3. Or we can say the whole list from beginning to the end. We drop the beginning and we drop the end, and it goes from beginning to end. So it's 1, 2, 3. We can get the length of the list by using the function length. Length is 3. We can get minimum of t, of minimum of a list. The 1 is the minimum element in the list. We can get the maximum by using the maximum function. Maximum. We can find the index of the first element in the list by saying, for example, t dot index 3. It means look into the list t, find the first 3, and give us the index of that, which is 2, because this is t. 0, 1, 2. So the index of 3 is 2. We can count the number of an element in the list by saying in the list of t, count all elements that are 3. Here we have only 1. So this is 1. And an interesting operation here. We can test if two lists are equal very easily. Let's say this is A, 1, 2, 3. This is B, 1, 2, 3. And guess what? A equals to B. Test this is if these two lists are equal. Very interesting. Very interesting. I love this one. So, what do you think will happen if I change the order of one of the lists here? For example, this is A. Let's say B equals 3 to 1. Do you think these are equal or not? No, they are not. The reason is because lists are ordered in Python. So the order is important and the index of the elements are important in the list. These are all common sequence operations. Now let's look at mutable sequence operations. These operations are only applicable on mutable sequences, means the sequences that can be changed. Those that cannot be changed, we cannot do this. But for the sequences that can be changed, like list, we can use this. We can set the element at the specific index. For example, we can say t of 0 equals 666. Look at t. We changed the element at 0 to 666. We can set couple of elements in one statement. For example, we can set the elements at index 3 and 4 to 8 and 9. Well, let's say t equals 1 to 7, 1, 2, 3, 4, 5, 6, 7. Now we can say t from 3 to 5 means two elements, element 3 and element 4, not 5. Let's make it 8 and 8. Both of them are 8. Look at t. Here, these two elements, 3 and 4, are 8. Or we can remove them. We can say t of 3 up to 5 equals empty list. Means remove them. It's very interesting how we can easily remove an element from the list, a range of elements. Now look at t. 8 and 8 are not there anymore. We can clear the list by replacing all the elements in the list with an empty list. So we can say t, all the elements in t from beginning to the end equals an empty list. So we removed all the elements. So look at t, t is empty. Now let's say t equals 1, 2, 3, 4, 5, 6, 6, 7, 8. We can delete one element from the list. We can say, for example, let's delete the index 1, which is 1. We can say delete t, the item at index 0, which is 1 here. Now look at t. 1 is not in the t anymore. It starts from 2. We can also delete more than one element. We can say delete t from the list 3 from 3 to 5. Now look at t. 0, 1, 2, 3, and for 5 and 6 should be removed. And if you look at here, 5 and 6 are not here. Or we can totally remove the list by saying delete T. So T doesn't exist anymore. Name T is not defined. Now look at this one. T equals 1, 2, 3, 4, 5. We can append to the end of the list by using the append method. T dot append 50. So look at the T at the end, 50 is here. We are appending to the end of the list. We can empty the list with two different ways. One of them is say T from beginning to end equals an empty list that we saw earlier, or we can call a clear method on the list. So T dot clear. We call the clear method on the list, and it makes the T empty. Now let's say T equals 1, 2, 3. We can copy the whole thing by saying T from beginning to end. It gives us a copy. Or by calling a copy method. We can say also copy. It also gives us a copy of T. We can insert an element into a specific index. We can say, okay, this is T, 1, 2, 3. We can say T dot insert into the element at index 0 with minus 10. Look at T. First element is now minus 10. We can get the last element from the list by using t.pop. This one removes the last element and returns to us. So t.pop returns 3, but the 3 is not in the list anymore. Look at T. It's only up to 2. We can also get an element from any specific index. For example, let's get this, let's pop this element at index 0, which is minus 10. So we can say T dot pop 0 minus 10. And if you look at the T, there is no minus 10 anymore. All right, let's go to sorting. Let's say T equals 3, 2, 1. We can easily sort this T by calling the sort method on T. Sorry, sort method on T. And look at T, it's now 1, 2, 3. Instead of 3, 2, 1, it's now 1, 2, 3. By using sort, we change the T list itself. So it sorts the T and stores in the T. So if we look at the T, T is also changed itself. But if we want to keep the T, only get a sorted list, but doesn't touch the T, there is another way. We can say again T equals 3 to 1. The T is 3 to 1, but I want to sort it without touching it. I will use the function which is called sorted, sorted T. So look, it returns a sorted list, but if I look at the T, T is exactly the same. T hasn't changed. Now let's say T equals 1, 2, 3. We can sort the T in reverse order. Reverse equals true. So look, T is 1 to 3, but it is sorted by reverse, like 3 to 1. Now let's use list as stacks. To add an item to the top of the stack, use append. So let's say a stack, we have a stack which is an empty list. We want to say stack dot append 1, stack dot append 2. And look at the stack. Okay, we add 1 and then 2. So we add to the top of the stack. To retrieve an item from the top of the stack, use pop. So this is the top of the stack. It's 2 here. So we say stack dot pop. So 2 comes out, and the stack doesn't have 2 anymore. It is also possible to use a list as a queue. However, lists are not efficient for this purpose. Doing inserts or pops from the beginning of a list is slow because all of the other elements have to be shifted by one to the right or to the left. To implement queue, use collections.dq, which was designed to have fast appends and pops from both ends. This is how we do it. We need to first import it. For example, we say from collections import dq, and then what's the problem? Oh, import is not right. Okay. Now we are importing dq from collections module. Now we'll say q equals dq, q dot append 1, q dot append 2. Now look at q, is of type dq, and there's 1 and 2. Now if we want to get this element from the right, we can say pop, like a stack. What if we want to get from the left side of the queue? We can say pop left. So q dot pop left, which returns 1. Yes. Look at the queue, there's no 1 anymore. Now let's go to an interesting topic. Python has a concept of list comprehension in which we can create lists using complex statements. For example, I want to create a list from 0 to 9. I have to say A equals to a list 1, 2, 3, 4, 5, 6, 7, 8, 9. What if I want to create up to 100 or 1,000? It's not easy to do that. It's not efficient. So we can say A equals x for x in range 0 to 10. So we are saying range is a function which creates a sequence from 0 to 1 less than this. So 0 to 9. So it creates a sequence from 0 to 9. And we say we want all x's that are in this range. So look at A, it's 0 to 9. I can say 100. Look at A, it goes to 99. It's very interesting and powerful. Let's say we want to create a list of the squares of 0 to 9. So we'll say A equals, there is a range from 0 to 10, but what we want is x to the power of 2 for any x in range of 0 to 10. So we want any x in range of 0 to 10, which is 0 to 9, and we want to make the square of them. So look at this A. 0 becomes 0, 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, and till the end. Or assume we have a list called WEC. WEC equals -4, -2, 0, 2, and 4. We can then create a list with the WEC values doubled. For example, I can say x, make it double, for x in WEC. So it goes to WEC from here, gets element by element. For each element in WEC, it multiplies by 2. So let's look at A. -4 becomes -8, -2 becomes -4, and the rest. We can also filter the list to exclude the negative numbers. For example, we can say a equals to x for x in vec if x greater or equal to 0. So now for any x in vector, which is this one, it checks this condition. If x is greater or equal to 0, it shows that. So it removes the first two. Let's have a look at A. There's all positive numbers. And the last thing is we can call a method on each element here. So we can imagine we have a names list, which is Reza and James, and we want to capitalize the first letter. We can say A equals name dot title for name in names. So what happens is names is this list. For each name, for each item in this list, we call it name. Call this method on top of the on that name. So let's see what happens. Reza and James, both of them are capitalized. Well, this was the second part of this tutorial, and I hope you enjoyed it. I will upload the next part next Wednesday. Please subscribe if you don't want to miss it. Also, please put a comment and let me know what you want to see in this course. Do you need more examples? Do you want me to be a little bit slower, or you're happy with the course? Thank you for watching,